In this video, we will look at finding the intercepts of g of x is equal to x to the fourth minus 81. If you're looking for intercepts, we're looking for the x-intercept and we are looking for the y-intercept. Now, as you know, to find x-intercept, we let y equal 0, and to find y-intercept, we let x equal 0. We'll start off by finding the x-intercept. So g of x is equal to x to the fourth minus 81. Keep in mind that g of x is the same as y equal to x to the fourth minus 81. Now, since this is not linear, what we'll do is try to factor this. So we have y equal to x squared quantity squared minus 9 squared. And now we said y is equal to 0, so 0 is equal to x squared minus 9 times x squared plus 9. That's the difference of squares formula. And then this here is also difference of squares, so 0 is equal to x squared minus 3 squared times x squared plus 9. So there's no sum of squares, so we can't factor that portion. So 0 is equal to x minus 3 times x plus 3 times x squared plus 9. And since this cannot be factored anymore, we set each factor equal to 0. So we have x minus 3 is equal to 0. We also have x plus 3 is equal to 0. And we have x squared plus 9 is equal to 0. If we solve now, so we have x is equal to positive 3. So we have an x-intercept here of 3, 0. So this is one x-intercept. If we solve here, we have x is equal to minus 3. So we have an x-intercept here of minus 3, 0. And if we solve here, we'll get x squared is equal to negative 9. So that means x is equal to plus or minus the square root of negative 9. So this is not real. So we have no x-intercept for this portion. So there's only two x-intercept here. These are the two x-intercept. Now if we go about and we look for the y-intercept, for y-intercept we have g of x is equal to x to the fourth minus 81. This is the same as y equal x to the fourth minus 81. And now we set x equals 0, so y is equal to 0 to the fourth minus 81. 0 to the fourth is the same as 0, so y is equal to negative 81. So our y-intercept here will be 0, negative 81. And it's very important that you point out which is the y-intercept and which is your x-intercept. Looking at this problem, we're looking for the algebraic test for symmetry. So keep in mind that there are three tests for symmetry. We have x-axis symmetry, then we have y-axis symmetry, and we also have origin symmetry. So there are three tests that we must test for when looking for symmetry. In the first test for x-axis symmetry, y will be replaced with minus y. So we have f of x is equal to 2 over x squared plus 5. F of x is the same as y, so y is equal to 2 over x squared plus 5. And now we replace y with minus y, so this here will be replaced with minus y is equal to 2 over x squared plus 5. And what we try to do now is to make this isolate the y so we could have it in the original form. So y is equal to minus 2 over x squared plus 5. And notice that this portion here is not the same as f of x. It is not. So y does not equal to f of x. So we have no x-axis symmetry. Okay? We do the same thing for y, but for y-axis symmetry, x must be replaced with minus x. So once again, f of x is equal to 2 over x squared plus 5, which is the same as y is equal to 2 over x squared plus 5. And now we're replacing x with negative x, so that's 2 over negative x squared plus 5. And if you take a negative and you square it, that is the same as if you have a positive x and you square it. So this is the same as x squared plus 5. Now since this portion here is actually what f of x is, so y is equal to f of x. So yes, we have y-axis symmetry. And now we perform origin symmetry. For origin symmetry, we want to make sure that x is replaced with negative x and y will be replaced with negative y. So f of x is equal to 2 over x squared plus 5. This is the same as y, so y is equal to 2 over x squared plus 5. And y is being replaced with a negative y, so negative y is 2 over, and x is replaced with negative x. And if we simplify this, we will see that we have negative y is equal to 2 over x squared plus 5, because if you square a negative, you'll get a positive. And isolating y, so this becomes minus 2 over x squared plus 5. And this here is not the same as f of x. So we can say that y does not equal to f of x. So we have no origin symmetry.